be kicking off from there.
All right, so I hope we can still hear me.
Yes, sir. Can hear you.
All right, all right, all right. So, good evening, guys, and welcome to the day class. And I believe we'll be enjoying this training so far. I believe it has been very resourceful to us. So, if the training has been very resourceful to you, I want you to give us a thumbs up. Give us a thumbs up if it has been very resourceful to you and you've been learning and enjoying the process. Yeah, thank you very much for that. So today we will be doing something nice. We'll be taking a step further to what we have been doing. So today we are going to be going into AI memory. We're, we'll be going into AI memory. All right, so let's understand the concept of this memory. What is AI memory? Now, the concept is we already understand that AI can reason, right? AI can reason and execute tasks. But now, you can imagine when you send somebody to go and buy something for you. Let's take, for instance, he said, okay, go and buy soap for me. And you gave the person some cash. And when the person went there, the person came back. The person bought the soap and came back with some change. You've sent the person an errand. Now you are now trying to say, okay, use the soap to go and wash clothes. Now, the person did not remember the last job that he or she executed because there was no memory. But if the person has a memory, the person will know, okay, I went to buy soap. Now, you are not telling the person, oh, I use this soap to do what? To go and wash clothes. Then the person will know, okay, it was this same soap that I went to buy that I'm supposed to use to do what? To wash clothes. Just this is the impact. Um, um, This is just the impact that memory has on AI. Just like what we saw now, when we initiate a conversation, after a particular chat, I say you send a message, it gives you a response. Now, when there is no memory, it won't be able to remember the last conversation. All right, it won't be able to remember the last conversation, but when it has a memory, then it will be able to remember the last conversation. Now, there are two types of memory in the AI. We have the short-term memory and the long-term memory. So I will give just a brief overview on them and then we'll push from there. So the short-term memory is a memory that, just as the name implies, short-term, it remembers your immediate conversation with it. Let's take, for instance, in your chat GPT, if you're chatting with chat GPT, you create multiple threads. So the memory that remembers the conversation you are having within a particular thread is the short-term memory because it's going to remember the conversation you are having in that particular thread. Everything you've talked about there, it will remember it. Now, long-term memory is when it wants to start remembering conversation across different threads. That is long-term memory. All right, so this is just the two type of memory. There are different types of long-term memory anyway. So in LangGraph, we use the LangGraph-Checkpointer for short-term memory and LangGraph-Store for long-term memory. So let's get started. Let's look at our basic chatbot. This is just the basic thing we did, part of the basic thing we did on Monday and Tuesday, on the day one and day two. So this chatbot is part of that, part of the basic thing we did on that day. So I'm going to run the chatbot. So let's run the code. We'll load our environment variable. I think I will need to um, increase my the font of my screen so that we can actually see it better. All right. So we load our environment variable and we initialize our LLM. All right. So wait for the LLM to initialize. So anyway, as this particular line of code is running, let's look at this. This is just the simple chatbot we built last time. Just one node, which is to make the LLM call. So this is just the basic thing the LLM call is doing. Take the state, invoke, pass the system message, and pass the entire state, and then update the state with the response. This is just a basic chatbot that which we have been building. So I don't know, this is taking a lot of time already to initialize. So I don't know why it's so, but let's just give it its time. Okay, so it's done. I don't know why it took so much time. All right, so let's compile our simple chatbot, and this is just the graph, simple chatbot. So just something that is simple and very basic. So we can get our query by saying that query is equals to we'll add a human message, add the content. All right, and the next thing to do is to say response is equals to graph dot invoke. So we'll pass the input. Our input will be a dictionary and we are writing to the messages. All right. And then it should be a list of the message. So cool. And okay, when we run this, we're going to get a response. So let's iterate in our response. All right, so let's run this simple graph now. And just very basic, you give it a question and it gives you a response. Now let's ask another question now. So let's say, how do I install VS Code on my Linux machine? All right. It gave us a response that is quite a long response. But if you observe, you see that the former response is gone. It only has just this one. Is that it doesn't remember the previous conversation because it has no memory. It's just an empty AI that just gives you a response. Now, how do you add a memory? How does it remember the last conversation? Because it's with remembrance of the last conversation it can actually use to execute more things. So to remember the last conversation, we need to add a memory to this AI now. All right. So let's add memory to the chatbot. So to add the memory, like I said, we need to use the LangGraph-Checkpointer. So from the checkpointer, we are going to import the memory saver. All right, so we need to import the memory saver. Now, what does this memory saver do? This memory saver helps to retain conversation in the AI. So once I add this memory saver now, so LangGraph in the hood manages how it gets this conversation and how it brings it out. Everything is already done in the hood. You don't need to do much. You don't need to do anything just to add this, and then it manages every other thing in the hood. But with what it does here is it uses the system RAM to actually run this particular one. So nothing is changing. We are building the same graph that we built before, the same chatbot. The only thing that is changing is we initialize our memory saver. And while we are compiling the graph, all right, we pass that memory saver, that instance of the memory saver as checkpointer. Now it sees that this particular instance here is the checkpointer for checking conversations. All right, so if you compile this, nothing changes. You're going to see your agent, your graph will just be that way, nothing changes. But this is the tweak now. This is what changes. Now, when you are trying to invoke, this is what changes. Remember, you make your query, you pass it as a human message. All right, you make your query, you pass it as a human message, and what changes now is that you need to add another information which is called the config. You see, we pass something here which is the config. So this is how you map it out. So we are going to add configurables and we're adding thread ID. Remember, this is a dictionary. So look at the dictionary how it is. This value here is the actual thread ID. It's always a string. Now we are passing thread ID here, telling the agent that, oh, any conversation that is under this particular thread ID is the same thread. Please manage them as the same thread. Now, if you change the thread ID here, it's going to get a different response. Now, let's go with this. I'm just asking, who are you? All right, and I'm passing 1 as the thread ID. So let's run this now. So who are you? I am an expert assistant, blah, blah, blah. Now, let's run another conversation. Let's say, how do I all right, I'm asking another question. Now remember, I'm still on the same thread ID. Now let me run this code now. You see that it retained the first conversation. It retained the first conversation, who are you? And then I am blah, blah, blah. And then how do I install this? So it retained this conversation, meaning that all this was actually passed to the AI. And then the AI actually has this knowledge. It retained this conversation so that the AI knows, okay, these are the questions you have asked before. I don't know if we are understanding me. So it now retained this conversation. Now, For you to understand this, I'm going to try and do something else now. Now, this is what I will do. I will pass a different thread ID here. So I'm going to say 113. All right, this is a different thread ID. Now let's run this. You see that it created a different conversion because it's seeing this as another thread. So it uses the thread ID to identify different threads. This is just how basically it works. This is just what it does. So this is how it remembers conversations, and it will be able to know that, okay, you've asked this particular thing before, you've asked this before, and then it will be able to, respond to you. Do you understand now? So this is just basically how it works. Now, I'm going to show you something now. This is a long running conversation now. All right, so I've made the first conversation. I'll make the second conversation. I've made the second conversation. So let me continue here. Let me say Windows here. We're still on the same thread ID. All right. You see that I had a response and it retained the entire conversation. Do you understand? So if I continue having this conversation now, let me ask it about Linux. All right, so I have more conversations here now. So if I continue running these conversations, you see that it will continue to grow. Just like, for instance, I want to show you something now. This is our response. All right, let's see how our response is. This is our response. So we've had how many messages? 1, 2, 3, 4, 5, 6, 7, 8. We've had 8 messages. All right. And if I go to the response and I go to the response metadata now, and I decide to look at the completion token here. The completion token here is 280. Okay, let me not, I need to check the total token. Look at the total token for this particular conversation. Now look at the total token for this particular conversation. Now look at the total token for this. You see that the token, the token consumption keep increasing. The reason why it is increasing is because whenever I'm making a query, look at that messages. It sends this entire conversation to the AI. So with this entire conversation, the LLM now knows, okay, these are the interactions you guys have had, and then it will be able to respond accordingly. All right, so and sending all these, the conversation will keep growing, keep getting much, keep getting large, and all that. And look at the two things that will happen. Two things. When this conversation grows and it will be much, the LLM might be finding it difficult to maybe comprehend some things because the messages are much. One, the latency will increase. Latency will increase. Two, your token usage will also increase. You find out that you can consume more tokens to actually get a little response when you are supposed to consume lesser token. So how do you mitigate this? It is an issue. It is a problem. So how you mitigate this is while the conversation is running at a particular number of conversation. When a particular number of conversation has reached, you pick some of the conversations and you summarize that particular conversation. Then you can actually continue the conversation. Now, at each message, you are still going to pass the message summary. Let's get to that so I understand what I'm saying. Okay. So to mitigate this, you are going to add message summarization. Now, what is this message summarization? How does it work? Just like I said, when the conversation is already very long, you are going to summarize the conversation. And once you've summarized it, it's going to reduce the token input to the LLM. So how you do this, there is another library we need to import. Now, after summarizing this message, you need to remove them from the messages state. That is the need of this remove messages. That's what we use it for. Now, we're going to be creating a separate state for us because we need another value, which is summary, to hold any summary that we run at any time. We don't want the summary to keep building up. So anytime we run a summary, it should override the one we have before. That's why it's just a string. And remember, we are inheriting from messages state. That means we still have our messages for storing the conversation. So this is our system prompt. Now, this is a prompt to help and summarize the conversation. Okay, so when you read what we have here, you see that it's trying to ensure that the summary retains the tone of the conversation so that you can reuse them. All right, so we're going to now define another node, which is our summarization node. So we're going to look at this summarization node in depth to understand how it works. So there is no much thing in it. So first of all, you pick your summary. You pick your messages from the messages. You pick your summary. Now, if there is no summary, return an empty string. All right. Now, if length of messages is greater than 10, that means if the number of messages in the messages state, okay, in messages is greater than 10, that means we want anytime messages is up to 10, please run summary for us. That is this. Then, if it is not greater, just leave this particular node, don't do anything. But it will execute anything anytime messages is more than 10. So once messages is more than 10, it will check, is there a summary before? Because it needs to know whether it has run the summary before or it's just running it for the first time. If there is a summary before, it picks that particular summary. Are you with me? And continue. If there is no summary, it says that there has not been summary so far. All right, that is, it has stored whatever it has now at the summary message. Now we are creating a template here, so which is very simple. Taking into account the previous summary, we'll pass the summary. Summarize the following conversation, we'll pass the conversation. So we are going to now format to fill in this variables here. So the summary is whatever summary it has there, and the conversation is these messages that we'll have here. We'll pass it at the conversation. So that if there is a summary, it knows the summary. But if there is no summary, it now has the entire conversation. And we now pass it to an LLM. We say summarize. We are passing this as a human message, and then this is the system message. All right, so it's now pick this and then run the summary. So once it runs the summary, we already have the summary in this response. That is why we are writing it on the summary variable. And then look at what we are doing here. So I want us to observe what is happening here. First of all, this is just delete message. What this will pick is the IDs of the messages to be deleted. All right, a list of IDs of messages to be deleted. Now, what happens here is this a list comprehension. All right, so first of all, we are iterating between the messages, and we are excluding, this is list slicing, we're excluding the last two. We're iterating from the first one and excluding the last two. Now, for each message, which will be in the MO, we are passing the ID of that message to this remove messages. So when we pass the ID here, that is what this person will have. Now, when we will try to add it here, it's now going to update this message state by deleting those messages that it has the ID. This is just basically how this line works. All right, so that anytime we are returning, it's deleting those messages and it's updating the summary. That is for the summarization node. Now, this is our LLM call node. A little bit of things changed. So what changed? We are picking our summary. If there is summary, get the summary. And then we now check if there is summary. Do you understand? Our system message will now add the summary there. But if there is no summary, we will now say pick the system message or the system prompt the way it is. And then we run our invocation and we return our messages the way it needs to be returned. Now we are adding this node as well in our system as a node. We added it as a node. Now look at our graph. All right. Now our graph now is running um, start to summarization node, from summarization node to LLM, from LLM to N, so that before it runs any generation, it's checked if the conversation there are much. If they are much, it runs a summary before it passes it to the LLM. So you see that we are now inside one agent. Now we are making two LLM calls. You see that it's getting complex. We're making two LLM calls, which is this, and we're also making this. So this is how you can continue adding different features to your agent while you are building yours until you will able to get what you actually want, or you will able to get it to behave the exact same way that you want it to behave. So this is how you can continue building and adding features and until you actually have what you need. I don't know if I'm making sense. I don't know if I'm making sense. Are you guys with me? All right. All right. Thank you very
Yes,
much for
with
that.
you.
All right. Thank you very much for that. So we've compiled our graph, and what we need to do next is to do what? To run it. Okay. So I'm going to add something here. Let me just say um, just say my name is Felix, and let's see how the conversation will continue. My name is Felix. Let's run this. Okay. Hi, Felix. I'm here to assist you. Okay, so I can ask a simple question. What can you do for me? Okay, it responded. The conversation is growing. All right, so let me just say, so how do I install VS Code on my Windows machine? All right, and the conversation is growing, and the conversation is growing. Okay, on my Windows machine. Okay, it's okay. So I think why this response is because of the prompt. The prompt was is not. So let me just say, how do I install VS Code? But what I'm trying to do, I just need us to have enough conversation so that we can actually understand what is happening. He's still misbehaving. Can't tell me how to install VS Code. Okay, how do I install extension on VS Code? All right, and we had a conversation. We had some response here. So as you can see, our conversation is growing. Okay, so let's go. How do I install Python extension? Let me ask it about Python extension. All right, if you watch now, you see that our message, the message that was returned now reduced. Why did it reduce? There has been a summary. There has been a summary of the conversation that we'll have here now. There has been a summary. All right. Now, if I print our response, remember our response is a dictionary, you see the messages, and then you see that summary has been initialized, and then this is the summary that we had. And this summary is being passed into the conversation where we are going. That is what it is using to maybe generate a better response. All right, so we can continue chatting with it. So, and you see that the message is growing up again. The message is growing up again. So if we print the response, you see that the message is growing up again. So if we continue chatting now, at a point, another summary will be done and it will be updated. So let me see if we'll continue on that. And so, and the conversation is growing. It's growing. We have 1, 2, 3, 4, 5, 6, 7. Okay, we need like two more conversations. All right, and you see that the messages are building up. Now let me run another conversation now. Now what is this thing? Why is my system hanging? All right. I don't know if you observed something here now. So if you observed, you notice that the messages has reduced again. And let me print the response this this other side. So, and you see what we have here. Okay. And when you watch what we have at the summary, you see that it's still saying the same thing, but the language has changed because LLM doesn't generate the same sentence, even though it will mean the same thing at the same time. All right, so it doesn't generate the same response, just like so. You see that the number of messages has reduced and summary has been updated. So this is just basically how you can add memory and it remembers your conversation. But remember, with the same thread ID, once I change this thread ID now, it's going to look for another conversation which might not be existing. All right, so this particular one is existing because we have the thread ID. All right, so this is just basically how it works. I don't know if we have question. Any question before we continue shooting? If you're following us today, can you give us a thumbs up? We are quite dull today. I don't know if we are actually understanding what we are saying. By now, I'm supposed to be getting questions. Someone should unmute and say something.
Mr. Felix.
Yeah.
I believe that we are all following.
Okay.
There are some of the concepts that we jotting on the flip side. So that we are making every moment count.
All right. All right. That's great. That's great. That's great. So this is just basically what it is. All right. So now the next thing I want us to do now is all this while we've been running a Python file on the Jupyter notebook. We'll be running our agent on the Jupyter notebook. So I want us to run it on as a Python file so that we can actually see, we can have the feeling and see how it is. Because tomorrow we'll be looking at deployment, so and everything should be run on a Python file. So I want you to see how you can move whatever you've done to a Python file. It's pretty very easy. All right, it's very, 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 very easy. So I can create a Python file here. I can call it the 44.py. And what I want is to transfer this particular agent, which we have built here, to that place. So what I need to do first of all is to import all my basic libraries. First of all, I'm going to select my Python environment. I'm working with this particular one. Working with this, okay. And just make all my importations. So I don't know why this is taking time to actually load, but let me continue my importation. Okay, and I need to get from Need to get the memory saver, and I also need from okay now I need to import delete message. No, sorry, remove message here. All right, so need to from all right, so this is me making the necessary importation. So I'm going to copy most of my functions. So I'm going to copy all these functions and paste them here. All right, that is great. And my LLM initialization, which I did here. So which is this? I need to pass them here, and I need to import. So I don't know if we actually understood what I'm doing. I'm just trying to copy these codes and send them to a Python file. All right. So that is just what I'm doing. So I'm going to copy my prompt now. So I'm going to copy the two prompts and send them here. All right. Then I also have the class that I defined. I'm going to define the class up here, which is the state that was inheriting from the message state. And it has the summary, which is a string. All right, so I don't think there is something I've not copied yet. I've copied all the major things that we'll need. So I've copied the remove messages, I've copied the memory saver, right? I've copied the memory saver, I've copied the state. All right, so I'm going to pass this particular code. I'm going to pass it to a function. So let's see what happens here now. So I'm going to pass it to a function down here. So we'll say define my graph. I can call it graph agent. I can call it graph agent, and I will pass my code here. So, but I need to import something. I need to import something. I think this thing is in from LangGraph.prebuilt. Yeah. import compile state graph. Let me see where this state graph is in. I've forgotten the location where this thing is. There something I need to import? It's not here. Compile state graph. It's not here. Anyway, okay, I can work without it. We can work without it. I just wanted to add the type of value that this is returning so that it also make it smart. So what I just need to do here is to return the graph. So I'm returning this graph that I've compiled. That's just what I'm doing here. So anytime I call this particular function, it runs this and returns, no, this is not return, and it returns this graph that we have here. So just as simple as that. Then what I might need to do here now, which is also very easy, is to create an instance of this graph. All right, to create an instance of this very graph. So how do I create an instance of this very graph? I can just say that graph is equals to graph agent. I think my system is running a lot of operations at the same time now. It's kind of hanging. So what I'm doing here now is I'm calling this function, and this graph now is having whatever this person returned. All right, then I can actually create another function. So this function now will be to chat with my LLM. All right, so what this function will do is just to chat with the LLM, just a very basic something that is easy. So I can just say define chat. So, and chat will be taking, it will be taking the message which I want to send to my agent, which is a string, and it will be taking thread ID. We remember that um, um, our agent takes a thread ID now, which is also a string. All right, so, and they should return a string as well. Now, inside here now, I'm going to constitute my message. Okay, this should not be message, this should be query. So that down here now I can have my message is equals to human message content query. All right, and then my config will now be equals to a dictionary configurable another dictionary where I have the thread ID, and then it can be whatever I want it to be. Let's say 1111. So here now I can have that my response is equals to graph dot invoke, and I'm passing my input The input is a dictionary. I'm writing to messages. It's taking a query, a list rather, of the messages, and then it takes config equals to config. So if this runs now and it was successful, we're going to get the current state of the graph here now. So what we need to do is to return. What we are returning is response messages, and inside the messages we are returning the last message, which is -1, and inside that last message should be an AI message, so we are returning the content. So with this we should be able to get this response and return this response. So we are partially done, or will I say that we are done actually. So what will happen here now is, once we import, what we'll be importing from this file now will be only this function. So anytime we import this function, it's going to run the entire file, and running the entire file is going to run this line of code here. And running this line of code, we run this function. And running this function, we run every other functions here that we need. And anytime we call this function, we'll be getting the actual response that we want. So this is just a simple way that you pass all those things we've been doing down to a Python file. Very easy, right? So let's run our code. We might be getting some errors, yeah? But if we have an error, then we'll rectify. So I'm going to say from day 44, import, what am I writing? Import chart. Let me check this chart. Why is it not seeing this file? It's supposed to be seeing this file. So, but anyways, okay, yeah, it's seeing it now. It's seeing it now. So let's run it. Oh, think it compiles too quick. Why? Okay, there's something I didn't do here. Sorry, I'm going to recompile this thing now. I'm supposed to pass thread ID here, the thread ID that we got from here, so that I can be passing the thread ID from the function. So I can be passing the thread ID from the function. So I'm just waiting for this restart to complete. Oh, I think my system is running a lot of operations at the same time now, and it's affecting me. Oh, yes, please. Let's just be patient, please. Oh, sorry guys, I mistakenly closed my browser while I was trying to close up some tabs that were open on my system. Um, right. Does this want me to close off VS Code now? Does this want me to close off VS Code now? Okay, so it's actually running now.
Hello,
Yeah,
is that Felix?
yes, that's so. Uh,
Oh, it seems like we were not my hearing you, so maybe like we're thinking that like you muted yourself or something.
okay, when I joined back, I forgot I muted myself while I was trying to join. So earlier, I mistakenly closed
Okay.
my browser while I was trying to close up some tabs that were open in my system. But I'm back now, and we are up and running. So we've been able to compile this, which is the chart. So we're going to pass in some um, questions. So let's just say response is equals to inside the chart. So the query. So the query is equals to who are you? All right. And then the thread ID, let's pass a string. Let's just say 1111 as the case may be. And then we want to print this response. So let's run this now, and you see that we actually got just a single line response from um, this man. All right. So what we did was in order. So what happened there is that we were able to pass all our code inside one file, and inside that file, you see that everything we've been doing has just been reduced to just one file. We are just importing this particular function here. So, and once we import this function, we'll be able to actually do whatever we wanted to do and other things that we actually wanted to do. So, this is just one of the easiest way that you can push your agent um, to your Python file after building from your VS Code. So we'll be drawing the curtain here today. So I'll be giving room for questions. So I'll be giving room for questions. Those that want to ask questions. So Danso is raising up his hand. So Danso, you have the floor, so you can ask your questions where you are confused. Definitely, I'll be sharing
Okay.
this code once we are done. I'll share this code on the repo so that each of us can get it. So,
Okay. So we spoke about using short-term memory and long-term memory, and I want to know the one that we demonstrated in this section today.
okay, what we actually demonstrated today is the use of um, short-term memory. All right. So, one what we are explaining, I explain what the tool we are. So we are using checkpointer. We are using the short-term memory, which is the memory um, in thread, the memory within a thread. So that is short-term memory.
Okay. And since um, with the final response, we okay. So there are we targeted using the final index, like to get the recent query that we made, so that like it didn't give us like the entire history, but just give us like a specific one.
Is it what we did
Am I
last year
right?
now, right?
Yes, yes, yes,
Yeah,
yes, yes. So like we just use.
what we did last year is we are trying to just like look at what we have. Our response gives us a dictionary. So inside the dictionary, we are looking for messages. Messages is a list. All right. So here now, look at it. Inside dictionaries, we are picking messages. Messages is a list. So since messages is a list, we need the last one. All right, so the last one is -1. And inside the last one, that an AI message. So we want to get just the content. So that's why we had that content here.
Perfect, perfect, perfect. I think my questions has been answered and my confusion has been cleared.
All right.
Yeah.
So do we have further
I don't know if
questions?
maybe um and like I have like another one, but it is not like related to this one. It is like related to the GitHub um I think the day two. The day two when we okay, so like when I visit the GitHub page, and I try to access the code base. Seems the page that looks like a certain way, like it's like kind of shaky. And when you hit the page, like to view the details, it behaves as if like there's a cooler running. I don't know if you could check that. And like I wanted to raise that point in my yesterday, but like you were not the one like teaching, so like I let it to slide.
So let me get to what you are saying as fast as I could. Okay, so this is the day two, right? Danso, are you with me?
Yes, please.
All right, so if
Yes, I'm
you
with you.
click it just the way I
So just
clicked it now.
let's see if you also get the same thing that I also got. You
Is it what
see.
is this what you were getting?
But mine was even like kind of shaking. Like mine was even moving up and down as if like we were running like a particular code.
No, 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 no. You shouldn't do that way. Though what you can actually do, there are two ways you can pick the entire repo here. One way is come here and click download zip. It's going to download the entire repo as a zip file. Or locally, you can just say um, this repo is open. So once I run git clone and I pass this URL, it's going to clone the entire repo on your local machine. So
Nice one, nice one. Think like that one even might skip me. Like me, am I cloning it and like having like direct access to it?
yeah,
Thank you
clone
very
it
much. I
or you
appreciate it.
download the zip file. Either ways.
Thank you. Thank you.
All
Thank you.
right. Yeah, do we have more questions? I think Ramsey left earlier. So Ramsey, we are rounding up. So we are at the question and answer segment. So if there are no more questions, then I should be pushing this to GitHub immediately so that we can actually access it on the go, right? But the floor is still open for anybody that has question to ask. All right, the floor is still open for questions.
Okay. I think I have like one more question to ask.
Okay.
So, now that we have this basic knowledge, I would like to ask you, since you have also been a starter before you go to this level that you are currently in, how do we fast track our experience and gain like enough confidence in like building great like projects to able to like connect us to maybe a higher audience or maybe like a higher gig or maybe like a bigger maybe like job of that sort. Thank you.
Build projects. You have to build projects. All right. So you still need to take a whole lot of courses. So at the end of this section, I will recommend some courses for anybody that wants to pick up and continue furthering. So I recommend some courses. Once you are done with your courses, build projects. You see, one thing about learning is your learning process. The main learning process starts when you are done or when you've completed a particular training. That's when the main learning starts. That's when you continue to develop. That's when you continue to build. Continue building projects. Continue trying different things, seeing how you can achieve a lot. So build projects. While you are building projects, while you are building portfolio and you are building experience. All right. Yeah. So that is even if you grow. That is even one of the easiest ways that can help you to land a job because you can say, "Oh, I have done this. I have done this." And the person will say, "Okay, these are the things that you can do." That means you can actually do this. So pick up projects and start building projects.
No, thank you very much. I appreciate
All
it.
right.
And I will be waiting out for the courses too. Now, when the
No,
time
that,
is
yeah.
due.
Once when we are done with the training, yeah. So that will be the next thing I will do. So all right. Thank you very much for the
Thank
time.
you.
So our video is still, I'm trying to round up the video. I want to upload all of them to a YouTube channel and then push them out so that it will be easier for anybody who wants to access them to just get them there. So the videos are available and I'll still push them out. So with the video and then the with the GitHub, you should be able to do a whole lot of things. So today's code is live already on GitHub. So pick the code and continue practicing. Thank you very much. All right, have a good day, guys. I'll be dropping now. I think some of us.
Yeah. No, thank you very much, sir. I
Yeah, thank
appreciate it.
you. Those that stayed to the end, Mohammed, Danso, Luke, Grace, and Ramsey. Thank you guys very much.
Thank you, sir.
Uh,
Thank you.
you're welcome.